Thanks for being here today, and we're excited to talk to you about NanoColor.
Yeah, why don't you go ahead with the slides. So yeah, I'm Doug Walker. I'm very pleased to be with you this morning. I'm the chief architect of OCIO, as Emily said, and very pleased to be here with Carol, to give a quick callback to Darren's inspiring presentation, is a serial volunteer if I ever met one. So,
as is Doug.
So we're very pleased to be with you here today to talk about a collaboration. And one of the great things about the ASWF is the opportunity to collaborate with other projects. So for OCIO, we collaborated. We had the opportunity to collaborate with OpenFX on their initiative to add color management to OpenFX 1.5, and we're here to talk about a collaboration with OpenUSD and MaterialX on a color management system called NanoColor. So we're going to talk, each of the projects kind of brought their own perspective to the project. We're going to go through those. We're going to talk in detail about this initiative because OCIO has a lot of stakeholders, many of whom are here today, and we want to give you a briefing on this to get your thoughts and feedback. Okay. So next slide. So we'll start with the OpenColorIO point of view on this. So to give you a brief history of the salient strengths of OCIO. So obviously it gives the people who manage the color pipeline at a studio control over the color space menus that the artists see in applications, and this includes not only the implementation of those color spaces, but also their names. OCIO is well adopted, and so it's a known quantity. People understand how to use it. They like the ability to create one config and share it across a variety of applications. And it's we try to keep it a well-managed open source project here at the ASWF. As people add new color spaces, we add support for them. I sometimes wonder why people are always adding new color spaces. You'd think the world would have enough at this point. I guess color scientists are just troublemakers, I suppose. But we try to keep on top of that and all of the platform updates and so forth to keep OCIO relevant for the industry. But despite that, we occasionally hear from people who say, we like what you're doing, but we can't use OpenColorIO for our project. And these are all things that we've heard. They tend to fall into two buckets, one being that it's too heavy for a certain application, or they don't like the idea that it requires an external config file that could get separated from an asset. So last SIGGRAPH in Los Angeles at the OCIO Birds of a Feather, we said, hey, what do you all think about doing a lightweight version of OCIO that we're calling OCIO Lite that could run in a web browser and things like that. And so at that point, I'll turn it over to Carol to continue the story.
So we talked about this last year, and we really just, at that point, were looking for feedback. What would this look like in an OCIO context? And the feedback was positive. At the same time, in parallel, we've been having discussions with MaterialX, their leadership, for several years now, as we knew that we had to find a way to make all of the color management between our two projects work together. The same went for USD. We've been closely tracking the progress of color management in USD, as USD is a very high priority to most OpenColorIO participants. And there's lots of overlap between these goals. And we're happy to say that since the beginning of this year, truly, we finally have a new initiative to collaborate on. OpenColorIO had several priorities for this initiative, and we'll talk a little bit later. We'll hear from Jonathan and Nick about their priorities for their respective projects. The first being for OCIO, we needed to be able to interop with full OpenColorIO. That's non-negotiable for us. So that means supporting all NanoColor features in OpenColorIO and supporting the meaningful subset of OCIO features in NanoColor. needs to do more eventually for us. Obviously, this is a work in progress, and it's going to take us a while to get here, but it's important for us to build from the bottom up to make this implementation of NanoColor be able to do more than just renderer color management. And it has to be able to provide some level of end-user customization, as to Doug's very apt comment of we're always adding new color spaces. We need to be able to do that, even if it is, for now, basic color, gamma, and matrix color spaces, along with some additional UI and UX conventions. So with that, Jonathan and Nick couldn't be here in person with us today, but they've kindly recorded some videos for us to watch.
Hello, I'm Jonathan Stone from the Lucasfilm Advanced Development Group, and today I'm going to talk about some of the motivations for NanoColor from the perspective of the MaterialX project. Just to give some brief background, MaterialX is an open standard for the exchange of rich material and look development content across applications and renderers. It was originally launched at Industrial Light and Magic in 2012, was released as an open source project in 2017, and became a hosted project of the Academy Software Foundation in 2021. Although our focus on the MaterialX project is material networks, we've long considered color spaces to be an equally important aspect of material description, as they provide the color triples and images in a network with their robust, unambiguous meaning. One of our core goals is to provide visual consistency for assets across different renderers, different applications, and different visual media, as well as maintaining the visual interpretation of assets over time. And color spaces are a critical component in achieving these goals. In the image on the right, you're seeing a good example of color spaces in the context of MaterialX, where we're rendering a MaterialX document for an asset called the Open Chess Set. This asset was originally created by an artist named Moeen Syed using Houdini Solaris, but you're seeing it here rendered in Maya Arnold, and it's commonly rendered in real-time engines and on the 3D web as well, where it needs to be interpreted in a visually consistent way. In this section, we'll talk a bit about the ideal properties for color spaces in the context of MaterialX. So one historically common approach has been for color spaces to be defined locally in a studio pipeline, but for a MaterialX asset that may be shared widely and repurposed in new media, it's important for the color spaces in the asset to be universal. This allows the color triples and images associated with these color spaces to have a consistent interpretation across renderers and over time, and makes it possible for the MaterialX asset to be equally valid in offline rendering, real-time rendering, the 3D web, as well as in future media categories that may not yet exist. Additionally, it's common in visual effects and animation to directly leverage the OpenColorIO library for the implementation of color transforms, but this approach doesn't extend well to all users of MaterialX. Ideally, the implementation of color transforms in MaterialX should be as lightweight as possible, minimizing any obstacles for new applications to adopt correct color space handling, and avoiding the need for any external data beyond the asset that's being rendered. In the current MaterialX codebase, we leverage a custom lightweight system for defining color transforms as graphs, but ultimately we want these definitions to be deferred to an independent industry standard such as OpenColorIO. With these specific ideals in mind, we can frame what we're hoping to achieve as follows: an industry standard that provides a universal set of color spaces with lightweight implementations of the transforms between them. With that framing in mind, I'll pass the mic to my colleague Nick Porcino at Pixar, who will talk about the motivations for the NanoColor project from the perspective of OpenUSD.
And Nick is apparently on a
Hello,
flight.
I'm Jonathan.
Nick is apparently on a flight to Denver as we speak, so he'll hopefully be available
For questions later.
for questions at the OCIO-BOF or other opportunities during SIGGRAPH.
Hi, I'm Nick Porcino of Pixar Animation Studios, and I'm here today to talk about Color in USD. OpenUSD is an industry standard format for composing and transporting information about scenes. Color information occurs throughout a pipeline, from capture all the way to presentation to an audience. Now, the bit that we're interested in today is this piece in the middle where USD and Hydra do their work. That bit is strictly concerned with the realm of scene-referred color. Scene-referred colors are those colors consumed by Hydra and lit and otherwise processed to produce final pixels in the frame buffer. Color management is implicit today, with the exception of an OCI-provided color correction task at the end of the pipeline. Although color space annotations in USD files exist, they're merely informative, not resolved within the pipeline. It's the responsibility of the renderer to ask Hydra to reach back into the scene graph for those annotations in order to apply appropriate colorimetry and transformation to the colors during the rendering process. There's one exception to that, which is MaterialX has the ability to apply color transformation to images provided as textures to nodes. That one bit of conversion really isn't enough. We're concerned about the color in scene description, and we'd like to provide accurate colorimetry within this domain. This domain is highly resource constrained. Within the innermost loops of the renderer, cycles, memory, and bus bandwidth are highly contended, and we must use those as effectively as possible. Not only that, we need our computation to provide identical results no matter where it's occurring, wherever that USD data can exist, no matter what renderer. So, how are we going to move from an implicit to explicit color management scheme without negatively impacting bus bandwidth, memory pressure, or available cycles, and provide compatibility with OCIO managed workflows, and reproducibility across every application that uses USD Hydra with a renderer to produce final frames? We're going to need some new thing. Everywhere where color is transformed or transmitted throughout the system, and that's bracketed by a full OCIO color management pipeline. And with that, let's have a look at how we're planning to accomplish that. Hi.
Likes to repeat the videos. So we talked for a long time between the stakeholders of these projects in many, many meetings over a decent amount of time to come to an agreement between all of us around what this project would look like and the initial scope and goals in an abstract form. The big question was how to build one library that meets the needs of OCIO Lite, USD, MaterialX, and other future use cases that we know are out there. We already know of a few. The big goal was to replace the currently bespoke individual solutions to the color management problem with a single universal approach organized around OpenColorIO because of the fact that we're, as OCIO, already an industry standard and implemented in many of the applications already used by our stakeholders. So to do that, we took a lot of time and actually wrote a charter with 6 goals in it, and we took a lot of time to come to an abstract representation of the high-level goals of this initiative, something that we can reference back to when we're deep in the weeds of implementation and wondering the best path forward. We thought it was really important, as this was a new initiative for all of us, to collaborate across big projects with big goals that aren't all necessarily the same. The QR code will get you to that charter. You can read more in detail, but we're going to speed through the basics really quick. Goal number 1, collaborate on the development of a lightweight, asset-focused version of OpenColorIO. 2, agree on a minimal set of reserved baseline color space encodings. 3, agree on a set of supported color processing operators allowed within this lightweight system. Ensure that, for the supported color operators from the previous point, the data model would provide smooth interop for applications using full OCIO. Document MaterialX and OpenUSD color space handling as input to eventual standardization. And lastly, deliver a best practices document with recommendations for interop with full OCIO and how to obtain the portability benefits of NanoColor. In parallel, mentioned earlier today, we started an initiative earlier this year called the ASWF Color Interop Forum, This is a separate forum from OCIO, a separate thing from the NanoColor project, but they're related in really specific ways currently. ASWF Color Interop Forum is a cross-project open space to discuss interoperability of color workflows and standards. So it's in this group that, in parallel to us forming this charter and working on how we're going to implement NanoColor, that this group was working on that set of color spaces that would be included in that standardized version of NanoColor for interop across projects. This QR code will take you to the draft first version of the white paper for that project, which, as of this moment, is open for feedback. It's in a draft state. We really need the community's feedback on this white paper. We want to make sure that this list of standardized color spaces suits everybody's needs, and everybody has a chance to weigh in and make their opinions heard. This is just a base level look at the contents of this color space list right now. It should look pretty familiar. There shouldn't be any surprises here. It's based on some things that are currently in MaterialX with some additions, also with some deletions that we hope will make things a little bit more compact and relevant to folks. And yeah, I think that that's all that we have time to say about NanoColor, about the Color Interop Forum today, but we look forward to your feedback throughout the rest of this time at SIGGRAPH.
And just to be clear, this list is intended to be sort of a minimal core set with the understanding that a system like NanoColor would allow people to add a custom color space that may be specific to their studio if so needed. So with that, let's dive into some of the details about what we've been working on. So again, this is intended to be a lightweight, versatile color management system that meets the needs that Nick was talking about in his video, or for example, an application that needs to run in a web browser. It's very important for us that NanoColor and OCIO exist in the same cinematic universe, if you like, by which we mean that there needs to be a straightforward path to interop with or upgrade to full OCIO. And we've introduced some limitations in order to meet these goals that we're going to talk more about in the coming slides. But the main one is that there's no support for user-defined configs or LUTs. That said, there is the ability for applications that want to customize the behavior by adding custom color spaces. So in terms of the processing model, it has the same powerful transform chain optimization as full OCIO, and the CPU and GPU rendering is simplified a bit from full OCIO, but it's utilizing the same code. So it's very important to us that you get the same results in either NanoColor or OCIO. This is the key limitation. So we're only supporting built-in configs. And for those of you who may not be aware, the OCIO library for a couple of years now has shipped with several built-in configs, and one of them, the studio config, is in fact a full ACES implementation. And it also has all of the color spaces that are commonly used in VFX and animation. So for many applications and users, this is all they, like this base with the ability to make some tweaks to customize it is often all that people need. So, and by making this limitation, we avoid the need for things like managing external config files in a browser, avoid the need for external dependencies like YAML and XML parsers and so forth. Obviously, it has excellent compatibility with full OCIO, and it provides a solid foundation for adding custom color spaces because you know what you're adding it into. So let's talk briefly about the data model. So in the blue rectangle are all of the transform types that full OCIO supports. And this includes things like 1D LUTs, 3D LUTs, various other file transforms. The orange box are the transforms that will be supported by NanoColor. And this includes only transforms that are analytic functions with a closed form inverse. And then within that box, there's a couple of specific transforms, matrix and exponent transforms, which are the ones that are needed to implement the ASWF color interop forum list. So we're calling out those specially because they're especially relevant for use as custom color spaces. So let's talk about interop, and we'll talk about interop in both directions, starting with NanoColor to OCIO. So the use case here is you have a full OCIO application that encounters a NanoColor-based asset that it wants to use. So there's two cases here. If it's just one of the core color spaces, the file format would just have the name string. That would be looked up in the NanoColor built-in config. If it's a custom color space, there would be parameters that would be passed into OCIO API. In either case, the result is a new color space that would be either merged into the in-memory version of the user config, and this is a new feature that we're working on adding to OCIO, or another option which already exists is for the application to convert from the original color space into a color space in the user config. Looking at the other interop direction, the use case here is an app using full OCIO needs to create a NanoColor-based asset. So we have a little decision tree here. So the first question is this color space one that exists in the NanoColor built-in config? If yes, you just store the name string for that. If that's not true, but it is a color space that can be serialized as a custom color space in this particular file format, then the parameters would be included in the file. And if not, if the color space uses 1D LUTs or 3D LUTs, for example, that would be unsupported in NanoColor. So if we talk about the NanoColor API, NanoColor will be a subset of the full OCIO API. This provides the best compatibility path with full OCIO. There won't be any confusion over mapping of concepts, and there will be no need to maintain two separate APIs. It'll be in the same main branch on GitHub as full OCIO, so it's just a compile time decision. You just set a CMake flag to compile either full OCIO or NanoColor. And finally, NanoColor will be maintained by the OCIO project, so it'll be overseen by the OCIO TSC and supported on our standard platforms of Linux, Mac, and Windows. So we're making good progress. We have a prototype. We'll have a link for you at the end how to access that. And we've created on GitHub a GitHub milestone for you to track the progress on this.
So we've talked a lot today, and we wanted to step back out and just remind everybody of the big picture of what we're trying to accomplish and how this might or might not affect your current color management workflows. We're moving towards more universal color management, the goal being easy interchange of color managed assets. Recognizing that our very flexible OCIO config approach that is used in full OCIO has trade-offs. NanoColor is a step towards making more universal assets for a very specific use case and will be interpretable without relying on an external config file. It's not intended to replace full OCIO. It's meant to fit in areas in your workflow where you have limitations like Nick or Jonathan discussed. So NanoColor versus full OpenColorIO. OCIO configs remain the preferred solution for sophisticated color management requiring lookup tables. Fully customizable configurations by staff at your studios, and dynamically updated configs. NanoColor color spaces are intended for file formats that need to be self-contained and portable and universally defined.
So let's look at it from the point of view of someone creating a file format. So there's various strategies. The first one is the traditional OCIO approach where the file format would store the name of a color space that would be looked up in a user-defined config file. A new one that we're adding is option 2, which is basically the same thing. You're still storing a color space name string, but in this case, it's one of the core color spaces that would be looked up in NanoColor's built-in config. And then there's a third case where and OpenEXR would be an example of a file format that takes this third approach. Is it's storing parameters which would then be fed into the OCIO API to generate a new color space. So we anticipate that various file formats will make different trade-offs and different decisions on how they want to work. So let's look at the considerations from the config author's point of view. So we're recommending that OCIO config authors add the ASWF color interop form recommended color spaces to their configs. And this will simplify the workflow if they need to import a NanoColor-based asset. And we should note that in a future release, OCIO will require that the definition of these core color spaces be that it must follow the specification. And the reason for this is to give asset creators confidence that these specific color spaces will always be interpreted and implemented in a specific way. Finally, let's talk about the strategies from the application point of view. So we want to make it very clear that NanoColor should be plan B, not plan A. So if you're already using OpenColorIO, please continue to do so. Apps that use full OCIO will be able to use any file format that assets that are created for NanoColor, because OCIO functionality is a superset of what's in NanoColor. So in summary, OpenUSD, MaterialX, and OCIO are collaborating on a lightweight version of OCIO. In parallel to that, we're working towards more interoperable color management across the various file formats in our ASWF ecosystem. And this has implications for file format specification developers, application developers, content creators, and color scientists. And your input is more than welcome, and we hope that this briefing will be a good starting point to a conversation over the coming days with you.
So yeah, how do you join? How do you get involved? Our next step, obviously development is in progress. We're looking for feedback. Our release date of something that we are going to put in the library is not finalized yet. That exact timing is flexible based on the feedback that we start to receive now that this branch is public. The first release, though, we will note, will likely happen prior to OpenColorIO's annual release next fall. So anticipate an additional release of the OCIO project next year. How to get involved. There's a bunch of different ways. We have working group meetings weekly. Join our Slack channels. Check out our GitHub milestone. And the QR code here leads to our now public branch of the NanoColor prototype. So check that out once you get back from all of your travels, and we look forward to your feedback. If you have feedback now, please join us tomorrow in this same room. Our OCIO Birds of a Feather is at 5 o'clock. We're going to be spending a large amount of that time in that discussion around NanoColor, because we know that there's a lot of things to discuss around this topic. And then if you're feeling social, directly after that, we'll be going to a place nearby to have some beers, and we hope you'll join us for that too. We want to say a big thank you to everybody who's just participated thus far in the NanoColor effort, including especially Nick and Jonathan, who couldn't be here today, but also Doug Smythe and Rick Sayer and Jessica Wang, who have all been really important stakeholders to get us to where we are today. Thanks a lot.
Thanks.